Can you solve this geometry challenge? Here's the question. Let's start with this equilateral triangle with a side length of 7 centimeters. And now at this point, let's draw a semicircle inside of it such that the side of the semicircle is tangent to the side of this equilateral triangle. And the question is, what is the area of this semicircle? Now you can pause this video if you want to give this problem a try. Now suppose you pause this video. Now let's see if you got the correct answer. So to answer this question is, of course, we will use the property of this equilateral triangle with a side length of 7 centimeters. Now since it is an equilateral triangle, it follows that it is also an equiangular triangle, meaning all of this angle must be the same thing. And since the total angle inside the triangle must be equal to 180 degrees, so one of its angle must be equal to 60 degrees because 180 divided by 3 will give us 60 degrees. Now let's focus on the semicircle. Let's get the center, of course. And now let's draw the radius directly to the point of tangency like this. Now since this side of this equilateral triangle is tangent to the semicircle, it follows that the radius is perpendicular to that side. So we have a right triangle. Right triangle right over here. This is a right triangle. Alright, now at this point, we know also that this angle must be equal to 60 degrees because all of this angle must be the same thing. And since it is a right triangle and we have 60 degrees right over here, so therefore the other angle must be equal to 30 degrees. So we have a 30, 60, 90 right triangle. Now also take note, this point right over here, the center point, divides the side of this equilateral triangle into two. Therefore, we can say that the hypotenuse of this right triangle must be equal to 7 divided by 2 or simply equal to 7 over 2 centimeters. Now, we will use the property of this 30, 60, 90 right triangle because if we know one of its side, for example, we know the hypotenuse, we can say that the shorter leg must be equal to half of it. And if we know the shorter leg, we can now find the longer leg because if we multiply the shorter leg by square root of 3, that is the length of the longer leg of this right triangle. Now, since the given is the hypotenuse of this right triangle, we know that the shorter leg is half of it, or simply the side opposite of this 30 degrees must be equal to half of 7 over 2, which is 7 over 4 centimeters. And since this 7 over 4 is the shorter leg of this right triangle, the longer leg must be equal to 7 over 4 multiplied by square root of 3. So this will give us 7 times square root of 3 all over 4. And now take note, this length, 7 times square root of 3 over 4, is also the radius of this semicircle. So we can now get the area of this semicircle because we know now the radius. Now at this point, what is the formula to find the area of a semicircle? This is just pi r squared divided by 2, or the area of the circle divided by 2. Now we can rewrite this as pi over 2 multiplied by r squared because we know now what is the value of r. We can now replace this r with 7 times square root of 3 all over 4. Now, if we square this, 7 times square root of 3, this will give us 49 times 3, and on the denominator we have 16. Now, 49 multiplied by 3, this will give us 147. And pi over 2 multiplied by 147 over 16, this will give us 147 pi all over 32. And that is the area of this semicircle. So the area of the semicircle, given this information, must be equal to 147 pi over 32 square centimeters. And as always, we are done.